Now one more solution from engineering mechanics meant for GATE students preparing for JEE Main 2021 and also for students preparing for All India Medical Entrance, that is NEET. Problem set 2.3, solution to 2.37. Again we will be applying Lami's theorem, that is for three concurrent forces in a plane. Look at the statement of the problem. A ball of weight W. Look at the diagram. This is a ball. Its weight is vertically downward. Weight is equal to its mass into acceleration due to gravity. It is a force. The earth is pulling it down. The center of the ball is A. This point is A, right? A ball of weight W is suspended from a string of length L. This is the length of the string. From this point to this point is the length of the string. It was initially suspended like this. So from here to here it is also L. This point is same thing as this point, that is the point A, the center of the ball. And is pulled by a horizontal force Q. The ball is pulled by a horizontal force Q. The moment you pull it, the string will make some angle with the vertical. The string will make some angle with the vertical. The weight is displaced by a distance D. The weight is displaced from this point, from this point to this point is D. The displacement of the ball towards the right, because you are pulling with a force Q towards the right. From the vertical position as shown in figure, find the angle alpha. Find this angle alpha. Force Q, angle alpha, force Q required and the tension S in the string in the displaced position. In the displaced position, that is in this position, what is the value of alpha? What is the value of Q, and what is the axial force, that is the tension force along the string. If the ball is in equilibrium, equilibrium means sigma F is equal to 0, that is sum of all forces acting on it is 0. So what is to be found out? We have to find alpha, we have to find Q, we have to find the axial tension force. Now let O is the point of suspension and this point is O. A is the center of the ball. Center of the ball is A. Line of action of Q meets the vertical dotted line. This is the line of action of Q. If you produce this to this side, this line of action will meet this vertical dotted line at this point, and let this point be represented as B. So we have a triangle now, ABO, right angled at B. So right angled at B. So the same triangle I have redrawn here, OAB. Now the question is, this angle is given as alpha. Since from O to A is the length of the string, this angle is alpha, and therefore cosine of this angle will be base by hypotenuse. So cos alpha will be this distance. This distance is same thing as this distance, is same thing as this distance, that is given as D. So BA is equal to D. So your cosine alpha is equal to base over hypotenuse, that is D over L. So alpha is cos inverse D over L. And we know from simple trigonometry, sin alpha is 1 minus cos square alpha square root of that, because sin square alpha plus cos square alpha is equal to 1. So you take cos square alpha to this side, take the square root, you get sin alpha. Now put the value of cos alpha here. Cos alpha is D by L, and here we have cos square alpha, so D square by L square. Take LCM. L square minus D square over L square, square root of that, L is taken out. So your sine alpha is found out to be 1 by L square root of L square minus D square. Then since we have found out sine alpha and cos alpha, let us draw the free body diagram at point A, where there are three concurrent forces. One Q to this side, one W to this side, and the tension force will be away from this. Let it be S. So I have drawn the free body diagram at point A. Q, W, S. Now the question is, this was given as alpha. This was given as alpha. Now W over sine of the angle between S and Q, that is the sine of this angle. This angle is 180 minus alpha. So W over sine 180 minus alpha is equal to Q over sine of this angle. That is the angle between the tension S and W. Sine of this angle. This angle is 90 plus alpha. So Q over sine 90 plus alpha will be S over sine of the angle between W and Q. That is this angle, which is 90. So S over sine 90. S over sine 90. Now if you consider these two fractions, equal fractions, and cross multiply, you get Q is equal to, this comes here, W sine 90 plus alpha over sine 180 minus alpha. Sine 180 minus alpha is sine alpha. Sine 90 plus alpha is cos alpha. And since we have put the value, we have found out cos alpha and sine alpha, now substitute the values of sine alpha and cos alpha. So your Q, the horizontal force that you had applied to the ball, equal to W into cos alpha is D over L. Sine alpha was 1 over L square minus D square, square root of that. So L comes to the numerator, L square minus D square, square root of that goes to the denominator, L cancels. So W into D over L square minus D square, square root of that is your answer. Now again, W over sine 180 minus alpha. W over sine 180 minus alpha is same thing as S over sine 90. Is same thing as S over sine 90. Now again you cross multiply these two to find out S. So W sine 90, sine 91, 1 into W, sine 180 minus alpha is sine alpha. Now put the value of sine alpha, 1 over L square minus D square, square root of that. So L comes to the numerator. So your S becomes W times L over L square minus D square, square root of that. That is the value of the tension in the string in this displaced equilibrium position, of the ball.